Hello again, this is John Lord and this is a follow-on to my previous video on using the Move tool within Litchi to move a pre-programmed matrix of camera positions to another location and then edit it. In that demonstration I alluded to a chart that I had put together for determining the distance between camera positions and so on. So if I pull up my pre-programmed matrix, we can see here on this matrix I've titled it X4S because that's the camera I'm using on the Inspire 2. 360 feet is the height I'm flying at. I require 50% overlap on the images, so at 360 feet to give 50% overlap, my images should be taken at 270 foot intervals in the horizontal and 180 feet in the vertical. So how do I arrive at those figures? Well, basically, it's based on the field of view of the camera that is being used. What I did is that I sat down and I worked out for all of the DJI cameras the field of view, and so I could then, from the field of view in degrees, I could work out what the actual field of view was in feet. So if I pull up one of the charts, this is my chart of the camera sensors. So I've done it for the Mavic Air through to the X7 camera with different lenses on and so on. So for the purpose of this example, I'm going to be using the X4S. Now the X4S, as does the Phantom 4 Pro, it has a 1-inch type sensor. It's not a 1-inch sensor, it is a 1-inch type sensor. And it has a diagonal distance of 15.86 millimeters. The actual sensor width is 13.2 millimeters and the sensor height is 8.8. The focal length on that lens is 8.8 millimeters, so it gives a diagonal field of view of 84.05 degrees, which is confirmed if you look in the data provided by DJI. But a diagonal field of view is not much use. What we really want to know is what is the field of view, the width, and the field of view in height. So basically I found a nice formula on the internet, which if you put the sensor size in and the focal length of the camera, it will work out the field of view for you. So that's how I arrived at all of these figures. So all I need to know is the sensor size, the focal length of the camera, and then you can work out the field of view. So that's where I started from. Then what I did from that, I can get the actual field of view in height. Now this is for still images, and it is using the full size of the sensor. Now when you record stills on, or take stills on the X4S, you can set it to 3:2, which is the full size of the sensor, or you can set it to 16:9. And if you set it by 16:9, it's using the full width of the sensor, but it's not using the full height. So these figures are based on using the full size of the sensor. So at 300 feet height, I have a field of view of 450 feet, so that's 225 feet either side, either side of me, and I have 300 feet field of view in the vertical, which means 150 feet in front and 150 feet behind. So using that data, then I can then work out what my distances need to be for a given overlap. So I normally use 50% overlap, and because that works well with PTGUI, which is the stitching software that I use to produce my final composite image. So if I'm flying at 300 feet, then with 50% overlap, it is indeed 225 feet between camera positions in the horizontal, and 150 feet. Or if I'm flying at 350 feet, it's 262.5 feet and 175 in the vertical. And just for completeness, there is a GST table, which is the ground sampling distance, and it's the distance between pixel centers in centimeters for a given camera lens and height in feet. So what does that mean? Well, what that means is that if I'm flying at 300 feet using the X4S camera, each pixel of the sensor is covering 2.51 centimeters of my image, and which obviously in old money or inches, in imperial, that is just under 1 inch, being 2.54 millimeters, I think, in an inch. So that is what I use for determining the camera positions. Now for video, that gets a bit more interesting, because I normally fly at around 300 feet and with the camera at minus 30 degrees. So I produced another table which gives me the distance. So here, the example I've highlighted is with the Mavic. This is the Mavic Pro, not the Pro 2, but it is, if I'm flying at 300 feet and I have the gimbal set at minus 30 degrees, then the closest point is 250 feet in front of the craft. So that means that the area that I need to cover, I need to be sure that I'm at least 250 feet away from it at the start. I'll probably show that in a example a bit later. And the furthest point is going to be 1700 feet. The closest point to the ground is 390 feet, because obviously we're looking down at an angle, and the distance to the furthest point is 1720 feet. So the distance between those two is 1450 feet. If I'm flying at 15 miles an hour, it's going to take 65.9 seconds to cover that distance. The field of view, the closest point, is going to be 500 feet, and at the furthest extent, so in other words at the bottom of my image, which is obviously my closest point, the field of view is 500 feet, and at the furthest point the field of view is 2,200 feet. So the distance between the rows, in other words, when I'm flying backwards and forwards, I need to have the distance set to something like 250 feet. That will give me a reasonable overlap. just to show what that means, I think I have an example here where I have done this. So if I pull up the example, as you can see, there are a lot of reserves that I've been doing. Because we've had such good weather, it means that I've been able to get out and do quite a lot. So here we go. Here is the example for a wood that I had to do. So the takeoff point here was at 200 feet. We went up to 300 feet and we can see the gimbal is at minus 30 degrees, and the distance here is the what I call the lead-in. In other words, I need to be ahead of where I'm going to film, so that I actually, in the video, actually takes in this area here. Of course, when I get to the end, this point here is actually going to be seen when I'm somewhere here, or it's going to go out of the picture when I'm around here somewhere. And I then fly about, and this is my lead in again for the next row. And I think you get the idea from this, and so on. So that's what I've done for video. Unfortunately, there are no formulas to produce this. Well, there might be, but it was quite complicated. So basically, I just resorted to getting some graph paper out, and knowing the angles and the protractor and so on, I was able to work all these out and then put these into the chart. So there we go. That's how I arrived at the different settings for cameras and so on, for still images and also for video. If anyone wants these charts, then drop me a personal message, and I'm happy to send the charts to them. And as and when new cameras come out, I will try and update the charts. So once again, thank you for listening, and see you next time.